Number 9 says simplify this given expression. If you look at this expression, we have numbers raised to powers. So this question is from indices. We have a number like here we have 8 to power 1 out of 3 and the rest of the numbers with their respective powers. For us to simplify this, we need to express the bases in terms of powers. Like we need to express 8 in terms of powers, we express 4 in terms of powers, we express 32 and also 16 in terms of powers. That is the first step. So this is the same question that I've written here to save our time. So the first step that we need to apply here is to express all the bases in terms of powers. So what is 8 in terms of powers? In other words, what number can be multiplied by itself for a given number of times to give us 8? The simplest way in most cases is for you to sketch a prime factor table. You can put here 8. Actually, you do it only for one number. You do the prime factor table for each number. You can put here 8. Then you say by 2, 4, by 2, 2, by 2, 1. Therefore, 8 is the same as 2 times 2 times 2. We are multiplying a number 2 by itself. In this case, 3 times. So, therefore, in the index form, 8 is the same as 2 to power 3. Simply because we are multiplying the base 2 by itself 3 times. So I've done this, and you can do it for any other number. But for the given example, and since you are candidates, this question is very simple. I will not show this for all the given bases. So 8 in terms of powers, it is 2 to power 3. But remember that 8 is raised to power 1 out of 3. So you keep the original power in that format. Time is 4. What is 4 in terms of powers? 4 is the same as 2 squared. I'm not going to show that, but if you represent it on the prime factor table, you will be able to get that 4 is the same as 2 squared. And then the original power was a half. Keep it there. Over, all of them over. What is 32 in terms of powers? If you draw the prime factor table to guide you, you'll find that 32 in terms of powers is 2 to power 5. If you multiply 2 by itself 5 times, it gives you 32. And then we keep the original power, which was 1 out of 5. That is the original power. Have a neat work, 1 out of 5. And then time is, what is 16 in terms of powers? 16 is the same as 2 to power 4. This is 2 to power 4. If you multiply 2 by itself 4 times, it gives you 16. And then the power is 1 out of 4. So we have expressed this in terms of powers. We have expressed the basis in terms of powers. Then we simplify. Remember from your indices, there is a law that says if a number with a power is raised to another power, then the new power is simply the product or the multiplication of those two powers. Therefore, we need to multiply the powers on each of the bases. So for the first case, we shall have 2 power 3 times 1 out of 3. You simply multiply those two powers. times 2 raised to the power 2 times 1 out of 2. Then we divide all of them by 2 raised to power 5 times 1 out of 5. And then times on the denominator here, we have 4 power 4 times 1 out of 4. So the law says if a number with a power is raised to another power, the new power is the multiplication of the two powers. Then from here, you press the calculator to multiply those powers. So here we shall have 2 power. What is 3 times 1 out of 3? It is 1. The 3 and the 3 will cancel. So here we shall have 2 to the power 1 times 2 times a half on the power. It is also 1. So this is also 2 to the power 1 over 2. 5 times 1 out of 5. The 5 and the 5 cancel. So we shall have 1 times I think I made a mistake here. If you notice it, this should not be 4 here, right? This was 2. This number here was supposed to be 2. It is not 4. So let me just erase only that part. If you notice that, thank you. It is supposed to be here 2 raised to power 4. From here just raised to power 4 times 1 out of 4. So the 4 and the 4 cancel. So here we shall have 2 power 1. And then we multiply. Remember, on the numerator here, we have two numbers of the same base that we are multiplying, right? 2 and 2 is the same base. The powers do not necessarily have to be the same, but as long as the bases are the same, then we add the powers. So here we shall have 2 power 1 plus 1 over, still it is the same expression on the denominator. So here we shall have the same base 2, so we add the powers. So here we shall have 2, 1 plus 1. So on the numerator, if we add 1 plus 1 on the power of 2, it gives us 2 out of 2 to power 2. If you look here, we are dividing two numbers of the same base. The base is 2 here and the base is 2 on the denominator. The powers can be the same or they can be different. But as long as the bases are the same, we subtract the powers. So from here, we shall just have 2, then we subtract the powers. So 2 to the power 2 minus 2. And this here gives us 2 to the power 0. Any number to power 0 is 1. So the answer is 1. Alternatively, even from somewhere here someone can take a different route from here. Someone can just say what is 2 to power 2, that is 4. On the denominator it is also 2 to the power 2, which is 4. 4 divided by 4, it is also 1. Or someone can say, okay, my base is 4 and each one has a power of 1. So it still gives us 4 raised to the power 1 minus 1, which is 4 to the power 0, and that still gives us 1. So there are very many approaches as we narrow down. So this is correct. If somebody had done this, this would also be correct. So this is the answer and the solution to number 9 of the Giant MOOC Examination Board Mathematics of 2024. And this is Vision Plus.